So now that we've got a handle on our sine, cosine, and tangent trigonometric functions, let's take a look at the last three. Now the last three trigonometric functions are reciprocal trig functions. The first one is called cosecant, then we have secant, and then we have cotangent. I'm going to work backwards. You'll notice that cotangent, shortened up to COT of some angle, is just tangent flipped over, or the reciprocal. So if you think right triangle trig, it's adjacent over opposite instead of opposite over adjacent, which is tangent. If you think of it in trig functions, it's cosine over sine as opposed to sine over cosine for tangent. So everything has been reciprocaled. If I look at secant, shortened up as SEC, that's the cosine function, reciprocal, or hypotenuse over adjacent. And the cosecant, shortened up to CSC, is the reciprocal of the sine function. Now, the way I keep these straight is I always talk about the two cos not coinciding. So you'll notice that cotangent was with tangent. That one's pretty easy. Cosecant is not with cosine, it's with sine. And secant goes with cosine. So every one of the pairs has a co in it. Cosecant with sine, cosine with secant, cotangent with tangent. That's how I kind of keep those straight. Now, the nice thing about these three trig functions is they are already on your unit circle. So if you go to pi over 6, look at the sine function at pi over 6, and you'll see it's 1/2. If I reciprocal that, it's 2 over 1, or just 2. If you go to -5 pi over 6, we're looking at the cotangent. Cotangent is cosine over sine, so I see the cosine there is negative square root of 3 over 2, and the sine is -1/2. So the negatives cancel. I have a fraction divided by a fraction. My 2's cancel, and I get the square root of 3. So the cotangent is already on there as well. Secant is related to cosine. So go to pi, find the cosine, and you'll see that the cosine is -1. If I reciprocal -1, I still have -1. So those values are all there. Now, if we come across trig values, or angle values that aren't, we're going to go to our calculator. If it's in degrees, cosecant is going to be the same as taking 1 divided by the sine of 35 degrees. By putting that in my calculator, I get roughly 1.743. Secant, that's related to cosine. So I'm going to take 1 divided by the cosine of 15 degrees, run that through my calculator, roughly 1.035. And another secant, this time I'm in radians. So I'm going to go to 3 pi over 2. This one's actually on my unit circle. If I take 0 and I flip it over, this is where it gets kind of tricky. When I flip 0 over, I get this, which is actually an undefined situation. So there are places where secant's undefined, cosecant's undefined, cotangent's undefined as well. Now let's take a look at what the graphs of these three reciprocal trig functions look like. So for our reciprocal trig functions, we're going to actually start with the trig function they come from. So for cosecant, cosecant is built off of sine. So I'm going to actually start with a sine curve as my basis. Now, I can put in all these values because they have not changed. But I have just a basic sine curve. What I'm going to do now is everywhere it crosses, remember these are zeros, if I reciprocal zeros, I get undefined situations. So everywhere that it crosses, I have these asymptotes. And everywhere I see a peak or a valley, I'm going to put in a parabola. Now what you see in blue is the cosecant function. And if I take out the sign that I used to help build it, there's what it looks like. It's a couple of parabolas, one going up, one going down, asymptotes in between. All I did is I took where it crossed, turned them into asymptotes, I turned the peaks and valleys into parabolas. So I'm going to do the same thing for the secant function. Now secant is built off of cosine. So I'm going to take the cosine function. Again, all these numbers are the same as it was for cosine. Everywhere it crosses, notice now it's crossing in between here, I'm going to put in asymptotes, just like I did for cosecant. Every peak and valley that I see, I'm going to put in a parabola. So I have half a parabola here, half a parabola here, and if I take out the cosine, I just kind of use that to help me build it, I'm now looking at a secant graph. Now with both of these, just like the regular trig functions, if I change the period, these numbers could change. If I do a vertical shift, if I do an amplitude change, if I do a phase shift, they're all going to change, but this is what cosecant and secant looks like. Now, the last one that we're going to take a look at is the cotangent graph. Now, just like we did with tangent, we graphed this a couple different ways. So I need to look at this a couple different ways with you. The cotangent graph has asymptote here and another asymptote out here at pi. But now the cosine or the cotangent kind of goes the other way. Now you might think this is just tangent with a negative sign, but the asymptotes have actually moved on this one. Okay, places where it used to cross, one up, one down, those are now where the asymptotes are at. So if you don't remember, tangent had one here and one here with an asymptote in between. I have taken the asymptotes and that's where it now crosses, and I've taken where it crosses, and those are now the asymptotes. So if you were doing the half and half version of this, where you put one half on one side and the other half on the other, you still have pi over 2 over here and a negative pi over 2 here, but now we have one going up and one going down. So it looks a little different, but we already know that the tangent graph does things a little differently. So these are the three reciprocal trig functions: cosecant, secant, and cotangent.